Hey, hello everyone. Alright, so today we will learn for optical instrument, right? So there are three types of the optical instrument. Okay, so the first one is magnifying glass, microscope, and also telescope, right? So we will see one by one. Okay, so the first one is the magnifying glass. So the function of the magnifying glass, right? So as you know, the function of the magnifying glass is to enlarge the image, right? And it consists of one convex lens. So later when we see about the microscope and also telescope, so we can conclude that actually all these three they use a convex lens. Okay, they use a convex lens. Okay, and another one is the position of the object for the magnifying glass. U is smaller than F. So we already learned in previous lesson. Okay, so how we want to draw the ray diagram, right? So what happens when U is smaller than F, where the object distance is smaller than F? Okay, so maybe you can try to look at the ray diagram. Okay, so the characteristic of the image, so when U is smaller than F, so of course it's a visual, okay, upright and also magnified. Okay, so this is the um, ray diagram for the magnifying glass. So this is the object. Okay, so it goes straight like that. Then it goes to the FO here. It will pass through the FO. Then another one it will pass through at the optical center here. So you can see there is no intersection here. So means you need to make this line longer. Okay, so when you make this line longer, you can see it can intercept, okay, at one point. So this is the image, right? So this will be the image. So as you can see here, the image is at the same side as the object. So it will be visual, okay, visual, and is upright and also magnified. Okay, the size of the image is bigger than object. Okay, now we look at the second one. Okay, so this is actually the microscope. Okay, wait for a moment. Okay, for microscope, okay, so the function of the microscope, of course, is to see the small object. Okay, so it's to see the small object. Okay, to see the small object. Okay, and another one, it consists of two convex lens. So magnifying glass only one convex lens. Okay, but for the microscope they have two convex lens. So the first one we call it as the objective lens. Okay, so this is the objective lens. So this will be the in front. Okay, the lens will be in front. Okay, while at the back is a eyepiece. Okay, eyepiece lens. So there are two type of lens here. So means they use a convex lens, but the first convex lens we call it as the objective lens. The second one is the eyepiece lens. Okay, and FO and FE. What is FO and what is FE? Okay, so this is your objective lens, right? So your FO is actually the focal length for the objective lens. So means from here to here. Okay, wait a minute. Okay, from here to here. So this is your FO, the focal length for objective lens. So that's why we call it FO. O is for the objective lens. So okay, from here to here is FO. Okay, what is FE? FE is the focal length for the eyepiece lens. So means from here to here. Okay, so this should be the FE. Okay, so this is FO and this is FE. So as you can see here, right, if you compare the length of FO and FE, the length of FE is much bigger than FO. Okay, so this is FE and this is FO. So FE is bigger than FO. So how about the position of the object? So the position of the object should be between FO and 2FO. Okay, so this is your FO, and actually there's another one. There is 2FO. So it's between FO and 2FO. So this is the object. Okay, then the characteristic of image formed by the objective lens. So this will be the image, okay, for the objective lens. So later we will see how to draw it, okay, one by one, okay. But I just explain to you, okay, briefly, okay. So the first one, okay, wait for a moment. Okay, so from the object, okay, it pass through the objective lens, right, and then we pass through the FO here. So F1 is actually the FO. Okay, so pass through the FO here. Then the second one, okay, we will pass through the center or the optical center. Okay, and this is the third one. Remember, there are three rules, right? If you want to draw the ray diagram. But for me, I will only use 1 and 3. But for this one, they use all 3, right? So now you can see there's intercept, right? Here. So mean this will be the image. So this is the first image that formed by the objective lens. Okay, so this is the first image that been formed. So the image that formed from the objective lens, there is a real, inverted, and magnified. So yes, this is one is real because the image is not same side as the object. So it's real and it's inverted, okay, and it's magnified, okay. So it's bigger than the object. Okay, and then so this one, the image for this objective lens will become the object for the eyepiece lens. Okay, so this image of the objective lens will become the object for the eyepiece. Okay, so after that, so from here, from the light ray here, it go pass through the second lens, that is the eyepiece lens here. From here you just go straight to the eyepiece lens. Okay, then you make it longer, it will pass through the FE here. Okay, so this line from here, okay, so from here go here. Okay, and for this one is actually you have this one, the lens should be longer. Okay, if not, all the light ray cannot pass through the lens. So for this one, from here go to here, then it will go here. Okay, and again this one also it will go here. Then after that you have to make it longer, okay, until it intercept at the certain point. Okay, so that one we will see later, okay, about the ray diagram. So this one I just explain to you briefly how to draw. Okay, then means the final image, right? So how about the final image? This one is the first image formed by the objective lens. So this image of the objective lens will become the object for the second lens, that is the eyepiece lens. So how about the final image? So the final image is actually visual, upright, and also magnified. But actually you already see this one, how can it become upright? It should be inverted, right? But actually we have to use another lens, okay, to make it upright, right? So we use another lens, okay, to make it upright. All right, so the final image should be visual, right, inverted and magnified. So after you use that lens, then it will become upright. Okay, so visual because the image is same side as the object, because this one is the object, right? Okay, so it's same side, if real, then of course the image will be from here. Okay, but since the image from here, so mean it's same side as the object. So this one, remember, this is the object for the eyepiece, so it's same side, right? So it's a visual, okay, and also it should be inverted, but after we use another lens, they become upright. Okay, and also it will become magnified, means the size, it will become bigger. So that is the microscope, and this is the ray diagram. Okay, FO is smaller than FE. Okay, maybe I just show you the last one, this one. Okay, yeah, this one. Okay, so this is the lens, the objective lens. So this is the object between F and 2F. Okay, then it go pass through the FO. This one pass through at the optical center, and you produce the image, the first image. So this image will become the object for the second lens. Okay, right. So this is the FE. Okay, This is the FE. So the object is smaller than FE. Okay, so just this one, make it longer, then it goes to FE. And this one, right, it goes at the center here. Okay, then you just make it longer. So the image will be formed. Okay, so this is the final image. Okay, so the next one is actually the telescope. So the function of the telescope is to see the distant object, right? To see the distant object. Okay, and it consists of two convex lens, and it's different from the microscope. For microscope, Fe is bigger than Fo, but for the astronomical telescope, Fo is bigger than Fe. So what is Fo is actually the focal length for the objective lens is bigger than the focal length of the eyepiece. Okay, and the position of the object, it should be distance or infinity, because we use telescope normally to see a star, a planet, right? And how does the light ray pass through the convex lens? It's a parallel rays. Okay, and the image is at the focal point FO. So this one later we will see the diagram. So you can be more clear about this one. Okay, and the first image is the real, inverted, and diminished. And the second object will be at FE. Okay, where's the focal length of the eyepiece? So that's the object. Okay, for the second, for the eyepiece, right? So U is equals to FE. So later we will see this one, right? So this is the drawing. So I just show you this one. Okay. So this is the objective lens, right? So this is the parallel ray. So it just goes straight, okay, pass through the optical center, and this one pass through FO, then go straight. So this will produce the first image, right? It just seems like the microscope just now. It produced the first image, okay, after it passed through the objective lens. And then this image will become the object for the second lens. Okay, that is the eyepiece lens. Right, so as you can see here, where's the object? This is the object, right, for the second lens. So this is also the FE. So this is also the FE, and this is also will be the FO, right? So that's why before this that U2 is equals to FE. So this is what does it mean? So the image will be formed at FE. Okay, right? This is the second lens, the eyepiece. Okay, then this is the diagram, go straight, and then this one pass through the center here, then you make it longer. So you can see there is no image being formed here. There is no intersection. So mean the image is at infinity. However, we already know the image is same side as the object. So the image should be visual. So because it formed around here, so means is visual, is inverted, and also is magnified. Okay, so that is the last image. Okay, so you can see FO is bigger than FE. So this is FO, this is FE. FO is bigger than FE. So how about the normal adjustment? So how you want to find the normal adjustment? You just add the length of the FO, add by the length of the FE. Okay, so let's say this is 10 and this is 5, so 10 plus 5. Okay, example like that. Okay, then how about the magnification? So this is the magnification, FO divided by FE, the formula. Okay, and this is the formula for the normal adjustment, FO plus FE. Okay, for the objective lens, so for the modification for the objective lens, so maybe you can use the big diameter, so it can so the light can enter more, so means it can produce the bright image. And the magnification, right? So the magnification should be bigger, so it can produce the bigger image. Okay, so that's all for this topic. Okay, and I want you to answer all the questions, okay, in your notes, and later we will discuss, okay, about this one. Okay, so that's all for me. So thank you, class. All right, bye.